Hi, my name's April. I'm a master's student at the University of Minnesota, working underneath Dr. Elena West in the Fisheries, Wildlife, and Conservation Biology Department. I have over a decade of experience working with mammals, birds, insects, and reptiles. In 2019, I came to Cedar Creek Ecosystem Science Reserve to conduct research on the spatial ecology of redhead woodpeckers, and have been working with this species ever since. The species you see here on my slides is the redhead woodpecker, which is in the top, and the eastern whippoorwill, which you see down below. Both of these species are declining in Minnesota, with estimates for whippoorwills being about 55% and redhead woodpeckers being closer to 96%. Both of these species are listed as greatest conservation need in Minnesota. Passive acoustic monitoring can help with detecting rare species on the landscape. By collecting audio data of the surrounding area, audio recording units like the one you see on the screen can easily be strapped to a tree and start collecting sound data based on any customized schedule. You can see here what the data looks like with the repetitive whippoorwill call on the top on what's called a spectrogram, and the distinctive quia call of the redhead woodpecker down below. In 2024, we collected data on the redhead woodpeckers from central to southern Minnesota. However, whippoorwills were detected by our audio recording units only at Cedar Creek Ecosystem Science Reserve. This summer, thanks to the Maxwell Hanrahan grant, we were able to focus efforts at Cedar Creek to capture crucial whippoorwill sound data for our research. From our 2024 and 2025 sound data, we hope to capture the deal cycle of red-headed woodpecker and eastern whippoorwill vocalizations during the breeding season. By this, I simply mean that our goal is to find out what time of day or night and what month through the breeding season these birds are calling. Where we are currently collecting data and are in the beginning of our analysis phase, we hope to find something like the bell curve you see on the screen depicting call frequency. To be clear, this is not our data, but if it was for one of our species, we would suggest managers perform surveys in June and July. We will also be using the data collected to evaluate performance of common programs used in audio analysis, such as BirdNet, Kaleidoscope, and Monitor. Ideally, we will be able to suggest to managers which program to use based off of usability and performance for these two species. Ultimately, we hope that our findings will increase detection probability of the redhead woodpecker and eastern whippoorwill, all while reducing field and analytical effort, giving managers more time to focus on other critical conservation work for vulnerable species. Thank you.
Hello, I'm Kristen Haynes, the Assistant Director of Rice Creek Field Station, a 350-acre preserve used for teaching, undergraduate research, and outreach at SUNY Oswego. We're located just 1 mile from the main Oswego campus on the shore of Great Lake, Ontario in New York State. In 2022, Kamal Mohammed, our station director, and I undertook a project to digitize Rice Creek and SUNY Oswego's plant collections by taking high-resolution images of plant specimens and sharing these and specimen data on web portals. The purpose was twofold: to secure our collection from any future damage and to share our specimen data with regional and global audiences. The learning curve for us was significant, but the rewards have been plentiful and tangible. So we wanted to share some of what we've learned to hopefully help other field stations looking to digitize their collections. First of all, you need an imaging setup, unless you'll just be sharing your data. We chose to use Ordery brand light boxes, which come with their own imaging software. However, a more flexible and probably cheaper option would be a copy stand with lights and a mounted camera. Your camera doesn't have to be top of the line, but it's nice to have about 30 megapixels for a crisp image. We recommend calling in a photographer friend to help you adjust your camera settings. Then keep those settings for each image. Second, barcodes are your friend for keeping data tied to a specific specimen and avoiding human error. We bought expensive archival barcodes before finally figuring out that we could make them ourselves with a mail merge in Microsoft Word and getting acid-free label sheets. Third, you will need to decide where to host and manage your images and specimen data. A great free or very low-cost option is to use one of Symbiota's portals. A great bonus is the very helpful support team at Symbiota. Remember, you will still want to archive copies of your images in a few other places for redundancy, like external hard drives. Fourth, consistency is key for entering your specimen data. We learned so much about this process from iDigBio's Digitization Academy, a free 40-hour program online that teaches you best practices for each step of the digitization process. We highly recommend this program. Fifth, you'll need to find people to help carry out the digitization work. The work is repetitive, yet it's a great skill builder for students interested in museum studies. We developed an internship program emphasizing these points of learning, making sure our students understood the bigger impact of the work and how this work could translate into careers by hosting Zoom sessions with museum professionals. We've had several students go on to seek jobs in the museum field based on their internship experience, and one is now working at the American Museum of Natural History. These are indeed unique skills that set students apart in the job market. Finally, you may need funding. We have been very fortunate to be supported by an NSF grant. Speaking with Program Officer Reed Beeman was very helpful at the start of the process. For those who have small collections, as long as you have willing labor, you may be able to start your project with very little funding. At the end of the day, one of the most gratifying parts of this whole process has been the immediacy of the impacts, not only for our students, but also for research. Symbiota portals can feed their data to GBIF, the largest data aggregator of specimen information. And GBIF allows you to track each time your data are used in a publication. We were astonished at how quickly our data started being cited. They've now been cited in 71 published studies. This is a very tangible impact to bring to administrators to advocate for the importance of your collection. We are more than happy to provide details about equipment, workflows, and more. Hopefully your learning curve can be easier and the rewards just as plentiful.
Hello, OBFS Conference. My name is Jenna Lilly, and I am a master's student in the Department of Natural Resources and the Environment at Cornell University. Some of you may remember me from last year's conference when I presented with Nancy Lowe about my upcoming research. Now, as I record this video, I'm in the midst of my first field season, and I'm here to share some updates with you. My research is at the intersection of art and science, where I'm studying the outcomes of and the barriers to art residencies at field stations and marine labs. In particular, I'm interested in gathering the perspectives of artists and scientists and administrators to help piece together the bigger picture. My methods have shifted away from the quantitative and are firmly into the qualitative to better capture the nuances of this topic. In-person site visits and semi-structured interviews form the backbone of my methods. In my first phase of research this summer, I visited 7 residencies at art institutions across New York State to gain a foundational knowledge of how these programs operate in an art context. These residency programs varied in structure, length of time, art mediums, resources available, and the size of the group. 2 of these residencies invited me to stay overnight, and I got to be a resident myself. Interestingly, although the science aspect was intentionally not the focus of these visits, science topics, methods, and concepts arose across nearly all of the sites. The second main phase of my fieldwork that I am in now consists of visiting field stations and marine labs with art residency programs, so art in a science context. By the time you listen to this talk, I will have visited 4 field stations this summer: Shoals Marine Lab, Cedar Creek Ecosystem Science Reserve, Hatfield Marine Science Center, and the H.J. Andrews Forest. Also, by the time you watch this presentation, I will have completed 18 interviews with folks from both the art-focused residencies and from field stations. This fall, I will have at least 2 site visits closer to me in the Northeast, and then I'll be looking forward into next year to plan another round of field station visits. I want to acknowledge everyone who's shown interest in my work, either from last year's meeting, through the Ecotones meetings, or through personal networks. I have a running list of everyone who has expressed interest, and I'm so grateful to the folks who have connected me with other friends and colleagues. Hopefully, I can be in person for next year's annual OBFS meeting and give you a larger update on my research. Lastly, this project is supported in part by the Cornell Rural Humanities Initiative from an award by the Mellon Foundation, and most importantly, it is supported by OBFS. Thank you for listening, and reach out with any interest or questions. Thank you.
Hello, and welcome to this presentation. My name is Ted Karfakis. I'm the director of the Calamus Island Biological Field Station. We are based in Calamus Island in the Ionian Archipelago in Greece. And today I'm going to present to you a few things about our experience running a volunteer program for more than a decade. All right, a few things about the station. We're a small local facility that is run by a non-profit called Terra Silvestris. We're a modest facility. We just have 2 staff, basically, which are members, which we make sure that they're always there. We have volunteers, we have field volunteers. We largely rely on volunteers to fulfill our mission, be it on a charity basis. We sometimes do interns. We work on land, sea, and freshwater. We mostly focus on the traditional communities, lands and waters in the archipelago, and to a much smaller extent in the mainland. We're an environmental conflict zone, okay? We have 2 classes of volunteers, on-site and remote. For the field volunteer program, which is basically part of our sustainable development program for the area, it's aimed to support that. For now, people do biodiversity studies, basically what we call the baseline biodiversity studies. Sometimes the work revolves camping. We work directly with members, interns, landowners, fishermen, collaborators. That's how the program runs. We work directly with the community, okay? So we are not a government contractor or a government collaborator in any direct way. Volunteers pay a fee to cover their costs. We have done a significant amount of biological research, including discovery of an endangered European pond turtle colony, monk seal colony, long-fingered bat colony. These are just some of the few examples of the rich work that we've done over the years. Data has been used to protect the ecosystem on the ground and has included legal actions. We have taken things to court. So, a few things about the program. You can see here, actually running it, simple bunk bed, mixed dorm bed accommodation, people living together, doing things in the field, on land and sea. It's a simple, I guess, proposition in an area that requires more than it could get from other sources. All right, so let's talk about a few of the lessons we've learned. All right, field volunteers and remote volunteers also come from mostly Northern Europe and United States. Most people come because they genuinely want to contribute, but we also do get, I would say it's about 40% of that, and 60% is more or less people who want to do this to gain experience in the field and see how the field is. We have an average of 18 to 30. Our minimum age of participation is 18 years old. We do have people that are professionals in the field, such as university lecturers at times. And this program has had more than 20 volunteers in the field at a time, so we do have quite a few people. Some are coming to do their own project, and some can be established scientists and practitioners at a time. All right, so basically, learning is there. Um, our goal is to produce scientifically accurate data that can be published in peer-reviewed journals, and for the research part. In the future, we want to do more on restoration, monitoring, and protection. Okay, right. So a little bit more than a decade of running the program. So yeah, partners are important. We can't source them on our own. It's just not efficient. It would take too long. We need someone to do that for us. We are significant for the local community because what we do is basically we don't do things without the consent of landowners, for example. We don't do things without, people actually telling us that it's okay or having been in one of those community meetings for the industry conflicts and actually have, an okay by the whole community. So we've done that as well. We, I guess, have a significant contribution to the local economy. Now, this is all based on trust, okay? So, I don't want to say that this was all peas and carrots. It can never be. It's reality on the ground. Good communication, alignment with organization cultures and volunteers and sourcing partners. So we all need to be basically aligned together in terms of the ethics of the organization and its philosophy and values and legal agreements and all that stuff. Problems have existed, but they have been solvable so far. Nothing that we couldn't solve. Overall program is a positive contribution to conservation of the local economy, and I would say very successful one. All right, so looking into the future, we want to get volunteers in direct conservation practice. We want to get educational institutions to come and help more, and other organizations. We want to get an environmental education program going with volunteers for the community. We want to expand program activities for the research component, and we want to expand our facilities, but that's a little bit more long term. But above all, of course, we can and would like to get more volunteers. And that's it. Thank you.
Hi, everybody. My name is Callie Pierce. I am the Preserves Manager for Sonoma State's Center for Environmental Inquiry. Today, I'm going to be talking to you about being realistic in grant applications. So first, we'll get into why we tend to overpromise on grants and what are the consequences, how to try to correct that, and then ultimately, why it's important to write proposals that you're actually able to deliver on. So let's get into it. All right. As we all know, we're applying for this very similar, if not the same grants. Everybody's got a good grant proposal. Everybody has a worthy project. And so grants are getting competitive, especially with funding drying up as it has been in recent times. So we want to make sure that we have that competitive edge. However, if we're overpromising on what we can actually deliver on, you're going to miss your deliverables, your staff is going to burn out, and you're going to lose trust with the funders. One example that we have at Sonoma State is back in 2023, we applied for a state coastal conservancy grant where we said we can do a 6-mile, 50-foot shaded fuel break on our Galbraith Wildlands Preserve, which, if any of you guys have ever been there, know that the terrain is crazy. There is a lot of understory and second growth. It's no easy feat. And so what had happened was we had never really done active land management before on the preserve. And so we were basing our scope of work, it was a collaborative grant. We were basing our scope of work on what other organizations that was within our collaboration were promising on theirs, because we thought, well, if they can do it, we can do it. However, caveat is, they all had either in-house restoration crews or they had long-term relationships with contractors. Whereas we were trying to use student crews and or early workforce crews like the California Conservation Corps, who we did end up actually having do our work. Ultimately, they did not finish very close to that. But what we were able to do is we asked for an extension from the grant funders. We explained the situation clearly. We were able to get additional funding through the California Conservation Corps. They had another grant that they were applying for, and they said, hey, we really want to continue working with you guys. We're enjoying this. How can we make this work? So we got some extra funding from them. You want to make sure that you are updating the key community allies, the key people that are within your funding and collaboration, because they need to be aware. They're going to find out one way or another, so it might as well be open and honest from the get-go. You can always celebrate small wins. Maybe not exaggerate. I'd never tell you to exaggerate a small win, but wins are wins. And, at this point, you'll take what you can get. So you want to make sure that you are writing proposals that deliver. You want to align your scope with your capacity. That's staffing, season length, equipment. You want to build in flexibility using terms like pilot, up to, phase-based. And then you can label stretch goals versus actual deliverables. Be transparent about risks like the weather, permitting, contractor availability. Ultimately, a grounded proposal means long-term credibility and repeat funding. So you want to keep that in mind when you're writing your grants, because by not being able to deliver, you're losing those things. Thank you. Good luck, everybody.
Hi, my name is Carol Blanchette, and I'm the director of a field station called Snarl in the Sierra Nevada mountains, and also a co-PI on an NSF-funded research project called Fuerte. One of the goals of Fuerte is to understand more about how undergraduate students benefit from a mentored field experience and how fieldwork influences the expansion of students' science identities and sense of belonging in conservation and environmental science communities. SNARL stands for the Sierra Nevada Aquatic Research Laboratory, which is a high-elevation field station that is part of the University of California's Natural Reserve System and located in the Central Sierra region near Mammoth Lakes, California. SNARL is a base camp for research across much of the Sierra backcountry, with research focused on environmental science and conservation. The Fuerte program at UCSB is a multi-year program funded by NSF that introduces undergraduates from backgrounds typically underrepresented in science to the world of environmental science through hands-on fieldwork, immersive research, and close faculty mentorship. Each year, a cohort of 10 first-year students is selected to participate in the program. The first summer, each cohort participates in a 2-week immersive field science course at SNARL. For many Fuerte participants, this program is their first real step into science, not in a classroom or lab, but in the wild. The SNARL course trains the students in data science, data collection, observation and analysis, as well as scientific communication. Throughout the course, the students have the opportunity to interact with other researchers and professionals in the field station. Many of the Fuerte students have never experienced field-based science, and it is especially impactful for first-generation college students and those from underserved communities who may have never envisioned themselves as researchers. So to investigate how the field course benefited the students, we asked them to journal about their SNARL field research experience, and the analysis of these free response questions is represented by this tree map diagram. It shows emergent hierarchical codes describing the students' overall SNARL experiences as a set of nested triangles, with the larger rectangles representing more coded responses. The tree map is scaled to best fit the available space, so the sizes of the rectangles should be considered in relationship to each other. The chart is organized with more frequently applied codes at the top left and of less frequently applied codes towards the bottom right. The map highlights the overall importance of the hands-on field research experiences, data science training, as well as the importance of peer and scientific support networks, the importance of place, and exposure to potential career pathways. The Snarl experience provided more than just research skills. It fostered identity development, peer support, and community building. Students with lower initial science identity especially benefited from supportive peer networks, not just research exposure. Hands-on fieldwork and data science opportunities gave students a realistic view of environmental science careers and strengthened their confidence as future professionals. Field research programs should emphasize both scientific skills and community building experiences to effectively support students' growth and persistence in environmental science. Our results suggest that field stations such as Snarl are more than just research sites. They serve as community hubs where students develop as scientists, explore career pathways, and build the skills and identity needed to thrive in environmental and conservation fields.
Research field stations hold decades of ecological knowledge, living archives of ecosystem change, but much of this information is locked away in fragile formats, at risk of being lost.
At the Organization for Tropical Studies, with support from the Ravi and Naina Patel Foundation, and in partnership with the Forest History Society, Bangor University, and the Environmental Data Initiative, we are rescuing and sharing legacy tropical environmental data from our stations in Costa Rica and South Africa.
These long-term datasets, tracking forest dynamics, species composition, phenology, climate, and more, provide the baselines needed for restoration, biodiversity monitoring, and climate adaptation. Working with staff, alumni, and principal investigators, we are collecting and standardizing priority datasets, georeferencing plots, and publishing open access packages through the Environmental Data Initiative.
Highlights include restoring forest plots untouched for over 20 years, revealing forest succession and species turnover, and revitalizing savanna and riparian forest data in South Africa to support fire ecology, mammal research, and conservation.
At our research sites along Limpopo and Saga rivers in northeastern South Africa, we've been curating long-term riparian forest datasets that track shifts in vegetation structure under rising elephant densities and changing climate. These records are crucial for understanding how elephants, fire, and climate shape riparian forests, and curating them ensures they remain available for future research and management questions.
As one of the data interns, I have to say that I've learned a great deal from the Legacy Data project. From data management, cleaning the data, sorting the data, these are some of the skills that I'll forever need in my scientific career.
Through this project, we worked with local partners to extract species locality records from our legacy datasets, making them accessible through the National Biodiversity Information System.
This is a collaborative effort, thanks to colleagues and alumni across OTS stations and international partners who helped recover records, confirm methods, and revisit field sites. By rescuing and sharing these datasets, we preserve the past to guide the future, supporting restoration, conservation, and climate resilience across the tropics and savannas.